My name is Abdurrahman Moghazi, and today I'm going to explain a very important concept from a paper called Human-Centered Autonomous Vehicle Systems, Principles of Effective Shared Autonomy by Lex Fridman. It was written in 2018. So let's start. Let's first answer or have a look at three essential questions, which are: is driving considered a simple or hard task? Are humans really bad at driving? Can humans and AI collaborate together? In fact, there are two main answers for each of those questions. The traditional approach answers those questions as the traditional autonomous vehicles approach, as driving is considered a very simple task, and that humans are really bad at driving, and that they are the problem actually, and that humans and AI cannot collaborate together to finish the driving task. But this approach, or the approach mentioned in the paper, answers those in a very innovative way. It says that driving is a very hard task, and that humans are very awesome and very good at driving, and that humans and AI can collaborate together to finish the driving task in a very good way and efficient way. So let's start first by defining what a human-centered autonomous vehicle is. Human-centered autonomous vehicle is a mix of collaboration between humans and artificial intelligence in a very efficient way. That human is doing the main task, but artificial intelligence actually is aiding him in some way. There are 7 shared autonomy principles on which the human-centered autonomous vehicles are based. And yeah, let's see what are those 7 principles. The first one is shared autonomy. The second one is learning from data. The third one is human sensing, shared perception control, depersonalization, imperfect by design, system-level experience. Before diving into each of those principles, let's explore some differences between the quality of sensors in traditional autonomous vehicles and human-centered autonomous vehicles. For the traditional autonomous vehicle, since the main task is perfecting the autonomous task, where the car actually is fully autonomous, so they try to perfect the task of perception of the car itself. So they need exceptional sensors in the perception task. On the other hand, human-centered autonomous vehicles need exceptional sensors to measure the state, or to have the perception of the state of the driver instead of the perception of the scene itself. Actually, it focuses on the perception of the scene, but the perception of the state of the driver, or the driver's state, is as important as the perception of the scene itself. So it uses exceptional driver state perception sensors. Yeah, let's start with the first concept, or the first concept, which is shared autonomy. Shared autonomy means that human is the main driver of the car. We do not get rid of him while driving, actually, or from the task of driving. Actually, he is the main driver. He is the main actor here. But artificial intelligence is trying to help him in a personalized way. Something like a driver assistance system. It can perceive the scene in front of him and alert him if he is not focusing on the driving task, if there is a high risk according to the sensors and the perception of both. The driver scene facing and the driver facing. We will get into this in a second. But AI can control some kind of easy tasks like steering, acceleration, deceleration, and it can give him personalized control to control the autonomous vehicle based on all experience or the experience of the driver himself. So the driver is aware of the level of risk, but how can this be done? It can be by alerting him using some kind of LCD screen in front of him, or some kind of voice communication using artificial intelligence systems. The second one is learning from data. Actually, we have, as I mentioned before, we have the driver's scene facing sensors and the driver facing sensors. The driver facing sensors' main task is to measure the state of the driver at each instant of time, while the driver scene facing its main task is to perceive the road in front of the car. It's a multimodal annotation where the data from the driver facing cameras and the driver scene facing cameras are annotated using a real-time clock so that we can relate the two the data at each the data from the driver facing and the driver scene facing cameras to each other at each instance of time. And those data are then used to fine-tune the neural network to give it a sense of personalization for each driver. The human sensing, it keeps the driver safe. It keeps him safe by measuring his state at each instance of time. It can perceive it using some kind of cameras or something like that to, as we see here, we can measure the activity that, or make some kind of activity recognition, the cognition load, the glance. We can see at every instance of time where he is looking and the activity he is doing. So he is looking off-road, and the activity is a smartphone. So he is looking a smartphone. The time he is spending looking off-road, and the time he is spending looking at his smartphone. Yeah, there's no external entities, and the estimated risk is high because he is looking off-road, so he might get off the lane or something like that. We have the shared perception control. The shared perception controls means that we don't exclude the driver from the driving task or from the perception task, but we need to grab his attention from time to time. We need to aid him if he doesn't see something because he is thinking of another thing while driving or something like that. It can alert him that there is something in front of you, so take care. And using these sensors from both the driver state facing and the scene facing cameras, we can they can merge them together to get an estimation of risk. So here there is a pedestrian in front of the car, and he can cross. He may cross the road at any instance of time, and yeah, the algorithm detects that Lex is not looking off road. He is looking on the road, and that he is not using his smartphone, but there is a pedestrian, so there is high risk. So take care and grab attention, and try to focus on the driving task. Here on the other side, he is not looking at the road. He is using his smartphone, and there are no entities, but it is labeled with high risk because he might deviate from his lane, or maybe something was not detected by the camera due to the imperfection of the algorithm itself. So he also needs to grab attention. The deep personalization. Deep personalization means that it's tuned for each driver, for each driver's use. It learns from the data from each driver himself, so that it can be personalized to each driver to give him an exceptional experience. There are two main types of learning. The fleet learning, which means that it can learn from all other drivers or from all other cars, so that it can learn on a huge amount of data. Then we use this model to be fine-tuned on the individual data collected from the driver himself during the task. For example, the communication task. It can be personalized using, think about the voice of or the way it communicates with the driver. It can be tuned on the data collected from the driver himself to be to give him some kind of personalized voice or personalized experience while communicating with him. Here we have imperfect by design. Imperfect by design means that the algorithm itself is not perfect. So we need to deliver this, or we need the driver to understand that it is not perfect, to grab attention to his road and to trust his machine, but not fully trust it, as it might make some mistakes. We need him to be fully aware of this. And this leads us to the next one, which means that he must be aware of every shared autonomy paradigm we mentioned before, or every shared autonomy paradigm in general, to be able to understand the machine better and to establish a trust relationship between the driver and the machine. In conclusion, human-centered autonomous vehicle trying to focus on the trust relationship between driver and system. It is not clear whether this approach can replace or is better than the traditional autonomous vehicles that are used right now, or not, but this might be revealed in the future. The solution tries to adopt the idea of perfecting the communication instead of perfecting the autonomous task itself. Thank you.